A very warm welcome to all of you. Myself Pravneet Kaur, Assistant Professor in CSE Department from RIMT University, welcomes you on a lecture of Software Engineering. Now, coming to the basic definition of software engineering, it is a branch of computer engineering which deals with the manifestation of software, that is, how the softwares are constructed, manufactured or engineered. Now, different softwares are developed according to the software development life cycles. Now, this is also known as SDLC. Now, the SDLC, the different phases of SDLC is called software development life cycle. We have got 7 to 8 phases of software development life cycle in which we develop how a software is constructed, starting from different phases like problem definition. I'll tell you the basic difference between all these 3 phases. Problem definition means the status quo. That means what is the current status of the existing system. Do we need to improve it? Do we need to modify it? Do we need to correct it? Or do we need to construct it in ab initio, from ab initio? So, what is the current status of the project? So, after that the problem definition is done, we have the feasibility study. Now, the feasibility study is the project which we are doing or the software which we are making is feasible or not. That means, is it possible? Is it plausible? The two terms are interchangeable. So, different kinds of feasibility studies are firstly economic. That means, do we have the enough capital to construct the software? Do we have enough money for it, or it is underpaid kind of thing? Then technical feasibility. That means, do we have enough technical know-how to create the software? Do we have the technical computers? Do we have the technical kind of softwares for building the software? And do we have that much technical people, the technical managers, the software engineers who can develop the software at a minimal cost? Then comes the operational feasibility, which is often forgotten. Operational feasibility means what a rapport we have between our horizontal hierarchy, that means the peer members, peer team members, and the vertical hierarchy, that means between our team leaders, our managers, software engineers and senior software engineers. So, that is how well we gel with our seniors, our peers, how well we are operational with those, as well as the behavioral feasibility. Behavioral feasibility is again the same, whereas operational deals with your operational costs also. Then the third step in software development life cycle is the requirements gathering. After stating the problem definition, after doing the feasibility study, now we have enough capital, enough money to spend on the software. We have enough technical persons to get the work done, and we have got the operational costs also under cover. Then is the requirements. That means we want to gather the different requirements of the project. Now, this is done by a person who is known as the BA or the business analyst. He may be a technical or a non-technical person who will directly liaison with the customer and acquire the different kind of requirements and then give it to the software engineer or the technical managers or the technical leads. Now, this requirements gathering is an important process, because whatever requirements are being given to the developer is being finalized, and hence it will lead to the software product. Then the fourth phase in the software development life cycle is the analysis phase. In the analysis phase, we analyze whatever information which we have got from the requirement phase. Actually, this is a formal documentation known as the software requirement specification, that is known as SRS, in which formally an analyst will specify or write in black and write that these are the requirements of the user and give it to the technical person in hand. So the analysis phase will give you the DFDs, that is data flow diagrams, flow charts and things like that. Next phase is the design phase. Now the design phase will consist of the flow charts as well as the blueprint of what you have to develop as a software engineer. Now this would have different algorithms, that means sequence of steps which will lead to the software. So all these algorithms are there, all the blueprint of the products to be made are there, and this would include a document that is known as SDS or Software Design Specification, in which we are actually defining or designing the part of the software. After the design phase, we have the coding phase. Now the coding will consist of whatever design phase has been developed, it is to be transferred into a form of programming language. That means we are writing different constructs, we are writing codes according to the design specifications. Once the coding is done, then the software engineer will see that if there are any errors or there are any defects. Now there are two different things which comes under observation, that is errors and defects. Now while the system or the product is being developed at the software engineer's side, if a kind of fault occurs, that is termed as error and it has to be debugged. Whereas when the product or the software is given out to the market and then as the customer feedback, the user end error is got, now that is known as a defect. So there are two terms which are used interchangeably, but the difference is quite minute. After the error and the debugging is done, debugging is just to catch hold of the error, whereas testing is to identify an yet undiscovered error. That means whenever there is an error, we have to find it beforehand. So that is done through testing. Now in testing phases, we have got different types of testing. Firstly, you can talk about the types here, white box and black box. Now white box testing is also known as glass box testing, in which only the logical constructs is being checked. That means only the logical flow of if else, do whiles, unstructured or structured constructs, they are being checked. It is known as white box testing and it is a logical testing, as well as it is also known as glass box testing because it is transparent to the user and to the software engineer whom he can finally see and correct. Whereas black box testing is known as the functional testing, which is not transparent. It is also known as functional because it acts at the ends of the inputs and it is input and output bounds error. For example, divide by zero error. That means the program is running good, but it depends upon the input of the user also. If we are giving something divided by zero, the error would be there because there is no logical mistake, but it is out of bounds mistake. So this is the testing types. Then we have got different testing strategies as well as types, which is known as unit testing. Then we have got integration testing. Then we have got system testing. Now unit testing means that small modules of the whole of the software is tested and the program is seen. Now when these modules are joined together to form a much larger part of the program, then comes the integration testing. That means two or larger functions are joined together and when they are tested again, certain errors might come. So for that we are using integration testing. Now after integration testing, the program or the system as a whole is being tested, which is known as your system testing. Then after the system testing, the whole of the software is fully tested. Again, coming to the validation testing. Now the validation testing will specify the two things. That means it is occurring at the site, it is not occurring at the site. So now we have the two things here, alpha testing and the beta testing. Alpha testing means that the particular software is tested at the software engineer site, and then some error comes up and it is correctified. Whereas beta testing is a type of validation testing in which the error is at the user end or the customer end. The software engineer is not present, and hence that has to be corrected. That is known as beta testing. Now above all, we have another type of testing known as regression testing. Now those testing occurs by vigorous testing and retesting of the software. When we are doing vigorous testing and retesting of the software again and again to correct an error, to modify a software, to debug an error, certain interfacing errors or certain errors do take place. So to avoid or to nullify those effects, we are doing a testing known as regression testing. So this was a brief overview of the testing strategies, that is the unit testing, the integration, the system. Then we have got stress testing. That means we are applying a number of inputs and the outputs and out of bound situations also, so that we will deliberately make the software to give errors at certain points. So we will test the durability of the software, and hence we can see how that particular software is purely tested, and hence it is error free or bug free. Now debugging and testing are two different things. Testing is to just fetch where the test or the errors are, whereas debugging is to remove those kind of errors, and with certain debugging tools which we have got, Selenium, etc. Many tools are there which are doing that stuff. Now coming to the next phase, which is known as the maintenance phase. Well, every situation, may be human being, may be softwares, may be any kind of projects or any kind of stages, any kind of softwares, any kind of hardwares, non-living or living being, needs to be maintained, and we need to have maintenance phase also. So the types of maintenance are, we have got the first maintenance type, that is corrective. That means any kind of problem which occurs and have to be tested fully, it has to be corrected, that is corrective maintenance. Then is the adaptive maintenance. That means if your software is working under Windows and the software has to work under iOS also, the software has to work under Linux also. So that is the adaptability. We have to adapt in all the situations. Humans adapt in all the situations, in all the kind of climate like winter, summer, spring, fall, etc. Hence the software also has to work upon or work under good conditions under every operating system, that is Linux, Unix, and here even DOS. So that is adaptive maintenance. Your software has to work in all the environments, all the conditions. Next type of your maintenance is known as preventive maintenance. Now preventive maintenance is if you're trying to find some error, or in future you detect that this error might come, then you should have certain preventive measures also being taken up as such. So that is known as preventive maintenance. Next is your perfective maintenance and enhancement. Now perfective and enhancement means that you have your software being made, but you want to enhance it For future references, you want to modify it for the betterment of the project or as per the requirements of the customer. That is known as perfective maintenance, or it is also known as enhancement. In layman's language, maintenance, we can talk about the corrective means we have a huge building, so we have certain problems occurring in the building, so we want to paint it, we want to renovate it. That is your corrective. Then is the adaptive behavior. Adaptive behavior means in sunlight, during rain season, during winters, during rainy seasons, the building has to be sturdy, so we have to put certain paints to avoid any kind of leakages, to prevent any kind of problems which occur. That is your adaptive maintenance. Preventive, in order to prevent any kind of damages or accidents, we have to make the walls stronger. Obviously, we want the walls to be stronger for the building, we want the base to be stronger, so that is a preventive measure. In case of perfective or enhancement, the walls are there, we want to paint them, we also want to do some artwork there. Now that is known as perfective and that is known as enhancement. So we are enhancing our project, we are working onto it. That was a simple case of a building, and it can be taken as a simple case of your software project also. Now the phases in the software development life cycle, a summary. For different projects, different software life cycles are used. Yes, your software life cycles are different. This was a generic view that we have got problem definition, then we have got the feasibility study, then we've got the requirements analysis, then analysis, design, coding, testing and maintenance. Now this is a very long procedure, and this will work only if the requirements are frozen in the beginning. That means we know the requirements which are there, but if we do not know the requirements and our requirements keep on changing after some time, or we are adding certain addition requirements to the already given requirements, then we need another type of models which are known as your prototype models, which are known as your build and fix models, and agile models and XP methodologies. So in prototype models, what we have the status quo, and then we are again building it, then we are again having the customer feedback, which is very important in it, and then we are changing our projects or our phases or our software according to the requirements given by the user and also the feedback. Now the customer feedback is very much important in the prototype model. So that is kind of rough model. A prototype is given before the actual delivery of the project, and then the customer uses it, and then he find out certain kind of faults in that, and then he specifies it and the feedback is given back, and again the project is refined. Now this is a kind of you can say prototype model. Then we have RAD model, or rapid application development model. In this kind of model, we have the model in which there are 60 to 80 persons, a small project is there, and then it has to be finished in 60 to 80 or 90 days. There is modularities in the project. Certain modules are given to one team, another module is given to another team, another module is given to another team. So such modules are being given so that the project finishes very fast. For example, one is the developer team, one is the tester team, one is the BA team. All these teams work together, and in the technical team also certain modules are given to different teams or 10 to 20 people, so that there is division of labor, there is no kind of stress on any of the teams, and they work interchangeably and effectively. So that was rapid application development model. When we need the project to be completed in very fast time. So that is what we have here in rapid application development model. Then is build and fix model. It is kind of similar to your prototype model, in which we are building and then we are fixing the model, then we are building and then we are fixing the model. Now in project management techniques, we have different strategies and we have different team members also. So for that, we have got to work effectively for a very good project, we have MOI strategy. That means motivation, organization and innovation. Obviously, we have to motivate, the leader has to motivate its team members to work effectively for the growth of the organization. Second is organization. Now, persons with similar traits or similar talents should be put together so that their technicalities are put into force and they give their best. So that is organizing the persons, the team members according to their talent, their technical know-how and their skills. Third is innovation. Now innovation is something which is known as new ideas to come up so that the project is made very good, very much new and not following the old precedented rules. It has to be a changed one and new ideas should be initiated and also appreciated. Now this was the different projects which follows different life cycles. So that all is being said here, that we have got quite a number of models which are used for different type of activities or software developments as discussed, but software development life cycle, a generic was which we have just discussed. Now this is in accordance with the requirements of the customer. Yes, this depends, the type of the model also depends upon the requirements of the customer. Whatever are the requirements of the customer, according to it we are discussing, we are getting the requirements, we are refining the requirements, and then there is the risk analysis. Another important model which would be here discussed would be the spiral model. Now the spiral model includes the risk analysis also. That means whatever is the unidentified problem which can occur at any time, that is known as risk. Now there are different risk factors and there are different risk mitigation steps which have to be taken, like the prevention, mitigation, and then again other risk analysis factors are there. For example, we have got physical, we have got technical and we have got non-technical risk factors. The physical factors are your natural calamities, the floods are there, the droughts are there, your PCs, they are troubled up, they are disturbed up. Then there are certain technical problems, risk, that is your system backups are not there, there is any kind of problems which occur. So these are already there in the system. So overall what we have discussed here is software engineering. Basically the definition here, it is a branch of computer science and engineering which deals with the development and manifestation of a software and its products. It is also used for the maintenance and the development of a software application. Then we have already discussed the software development life cycle, its full stages. That means what are the different phases which occurs in the making up of a software generally, that is your software development life cycle, and its different phases which are starting from your problem recognition, from your feasibility study, analysis, design, coding, testing, and your maintenance, And that is all for now. Thank you so much. Thank you for your time.